Welcome to The Explainer. Today we're diving into a classic developer headache. You know the one, you're building a slick Go application, but a third-party API just can't seem to make up its mind and keeps sending you data in different shapes. So, how do you build something solid when your data source is, well, unpredictable?
So let's just set the scene for a second. You're building your service, you're calling an endpoint, and you're expecting this nice, clean, predictable JSON to come back. But then, it doesn't. You get something in a totally different shape. And this isn't some rare theoretical problem, right? This is a super common, super frustrating issue that leads to crashes, weird bugs, and way too many late nights spent debugging.
Okay, let's look at a real-world example to make this concrete. Imagine you're working with a hotel API. All we care about is the galleries field, which is supposed to have image data. Simple enough, right? Well, this is exactly where the trouble starts. And just look at this. The API can return that galleries field in two completely different ways. On the left, you've got a simple, flat array of items. That's clean, it's easy, we love to see it. But on the right, we get an object where the keys are these dynamic types, and then the values are arrays. It's the same data conceptually, but it's being sent in two totally incompatible structures. Now, this is where Go's biggest strength, its strict static typing, suddenly feels like a huge weakness. A Go struct that's written to expect an array is going to panic the second it sees an object, and a struct expecting an object will fail on the array. Either way, you're pretty much guaranteed a crash, so we're forced to get creative. So what's the first thing we all think of? Let's go down that path and see why the most obvious fix can actually create an even bigger mess down the line. The thinking usually goes something like this. If a field could be anything, why not just tell Go it could be, well, anything? And that leads us to the classic first attempt, declaring the field as an empty interface, or any if you're using modern Go. And you know what? This works. Kinda. The JSON parser will happily dump either the array or the object into this field, no complaints. Problem solved, right? Not so fast. See, this solution isn't really a solution at all. It's just kicking the can down the road. You've avoided a crash during the initial parsing, sure, but you've just pushed all that complexity and uncertainty deep into your application. Now, every single piece of code that needs to use this data has to constantly check, hey, are you an array or are you a map? What are your keys? Are you nil? It creates this absolute nightmare of brittle, defensive code that's just a pain to maintain. But what if there was a better way? What if we could actually handle all this complexity right at the source? What if we could just absorb the inconsistency right at the boundary and present a perfectly clean, predictable structure to the rest of our application? Well, that is the idiomatic Go solution, and it is incredibly powerful. Go gives us this fantastic tool for exactly this situation, unmarshalled JSON. You can think of it like a special, custom-built translator that you attach right to your data type. By implementing this method, you're basically telling the JSON parser, hey, hold on. Don't use your default rules for this one. I'll take it from here and show you exactly how to handle this messy input. And that is the beautiful part. This is the core benefit right here. You stop scattering all those messy type checks all over your codebase. You solve the problem once, in one place, right where the messy data comes in. The rest of your application never even has to know that the API is inconsistent. It just gets a clean, reliable slice of data every single time. Okay, so this sounds great in theory, but how does this custom method actually work? Let's pop the hood and take a look. The strategy is actually surprisingly simple and elegant. The logic is just so simple and powerful. First, we try plan A. We try to unmarshal the raw JSON as a simple, flat array. If that works, awesome, our job is done. If it fails, no big deal, we just move on to plan B and try to unmarshal it as a map of arrays instead. And if both of those attempts fail, well, then we know the format is truly something we don't recognize, and we can return a clear, explicit error. And here's the proof in the pudding. The tests show it works perfectly. We write a test case for each of the JSON formats, and our custom unmarshaller just sails through both of them. It correctly parses the flat array, it correctly parses the object with keys, and it gives us real confidence that our code is truly resilient.
So, what's the big takeaway here? This technique goes way, way beyond just fixing one tricky field from a flaky API. This is really about a fundamental approach to building robust, professional software.
The source material really just hits the nail on the head with this quote. The real world is messy. Data is messy. APIs have bugs, they get updated, and they sometimes send back weird stuff. Our job as engineers is to build systems that can handle that mess gracefully, and custom unmarshalling is a key tool in our toolbox for doing exactly that.
So by investing just a little bit of effort up front, you completely transform a potential source of runtime panics and nasty bugs into a clean, predictable, and easy-to-maintain interface. And that's the difference between brittle code and solid professional code. This isn't just a clever workaround, it's a go best practice. And that leaves us with a final question for you to think about. Look at your own projects. Where are you passing messy data around your system? Where are you writing those endless if statements and type assertions? Because as we've just seen, there's often a much better way. Handle that complexity right at the source, and let the rest of your code enjoy the benefits. Thanks for joining us on The Explainer.